In this video, I'm going to be going over all 8 of those practice balancing equation problems. What you should be doing is trying all of them on your own. If you get stuck, you can watch these videos, and then you could also watch them when you're done so that you could check all your answers as well. All right, so the first thing we always got to do, we got to separate our reactants from our products, and then we got to make sure we're balanced. So let's see how much we got potassium here. Let's see how much potassium we got. We got 1. Chlorine, we got 1. And oxygen, we got 3. And then on this side, potassium, we got 1. Chlorine, we got 1. So those two are balanced. That's nice. Oxygen, we got 2. Uh-oh. So now we need to make sure our oxygen are balanced. So I'm going to change my coefficients with a pencil. So we have to increase our oxygen on this side. So let's throw a 2 here. And when we put a 2 there, got to cross this out, that becomes a 4. Now we got to increase our oxygen on this left side. So I guess we got to put a 2 here, which increases everything. So if we do that, 2 potassium, 2 chlorine, and 2 times 3 would be 6 oxygen. So now we need more potassium and chlorine on this side. So we could put a 2 here. And that would give us 2 potassium, 2 chlorine. Now we just need to balance our oxygen, and we could do that by changing this coefficient to a 3. So if that's a 3 now, we will have 6 oxygen. So now everything's balanced out. So our ending coefficients, we'd have 2 KClO3s, 2 potassium chlorides, and 3 oxygen molecules. Now for the next one. Let's draw a line right down where our arrow is. We got our reactants on the left side, products on the right side. And this one we only got 2 things. We just got sodium and chlorine. So let's see. We got 1 sodium, 2 chlorine, and on the product side we got 1 sodium and 1 chlorine. Our sodiums are already balanced, excellent. We have less chlorine on the product side, so we need to increase that. So we only got one option here of what compound to increase. So let's increase our sodium chloride. That gives us 2 sodium and 2 chloride. And now we just need to increase our sodium. And it's really easy when you just have one element here, it's not attached to anything. You could always just increase it by whatever you want. So we throw a 2 there, and look at that. We got 2 sodium on this side now. And that is balanced. So we got 2 sodium, 1 chlorine. And when it's a 1, it's just automatically assumed, so you don't have to write a 1 down there. And 2 sodium chlorides, and that would be balanced. All right, so number 3, here we go. We gotta split our reactants and our products because their masses have to equal. And our elements here, we have carbon, And on the reactant side, we got 2. Hydrogen. And on our reactant side, we have 4 of those. And fluorine. And we got 2 of those. And on our product side, if you take a look, we have 4 carbon, 8 hydrogen, and 2 fluorine. So the only thing that's balanced right now is our fluorine. So we need more carbon and more hydrogen on our reactant side. So let's increase that coefficient right there. And we'll see what we get. Now we have 2 times 2. We got 4 carbon. And 2 times 4, 8 hydrogen. So just by changing that one coefficient, that is now balanced. So this would be a 1, and that would be a 1 as well. All right, problem number 4. And again, this one, we're splitting it right where the arrow is. Mass has to be equal on the left side and right side. And you can see here, this is a sign it might be a little bit easier. We got one element just all by itself, so we could always just add more if we need. So we got 1 iron, we got 2 oxygen, and we're making iron oxide. So over here we got 2 iron, 3 oxygen. So I am going to balance. I know iron will be really easy to balance at the end because I can just change this number to whatever I want. So I'm going to balance the oxygen out first. So let's throw, I need to make it larger. So let's throw 2 here and see what happens. So if I throw 2 there, I could change that to a 4. Because that's how many oxygen I have now. But now I got more oxygen on my left side than my right side. So now I have to increase my oxygen on my right side. And the only way to do that is by adding a coefficient there. But that changes both my iron and my oxygen. So now I got 4 iron and I got 6 oxygen. So now I got to go back and change my oxygen on my left side. In order to get 6, I would need to increase my coefficient by 1 more. So I can make that a 3. And 3 times 2 would be 6. So I can adjust that. And now I just have to make my iron balance out. So I need to make sure I have 4 iron on this side. Easy adjustment here. I just have to add a 4 in front of it, a 4 coefficient there. So my answer, let me finish my work here. If I add a 4 there, we got 4 iron. Iron balance out, oxygen balance out. Excellent. This will be my answer with the right coefficients. All right, halfway there. Let's take a look at problem number 5. This one looks like it might be a little tricky. We got sodium. We have oxygen. We got hydrogen. And we got sulfur. So we got 1 sodium. Now to look at for oxygen, I gotta look at both my molecules there. So I got 5. Same with hydrogen. So I got 3 hydrogen and just 1 sulfur. Let's see what we got in our product side. Two sodium, 1, 2, 3, 4, 5. 5 oxygen. Excellent. So that's balanced. At least one's balanced. 2 hydrogen from the water and 1 sulfur. All right, so let's balance out. I mean, we could start anywhere we want, but let's start with sodium just because that looks like it might be easier. We'll see. So if we put a 2 there, we are going to increase our sodium to 2, but we're also increasing our oxygen. So our oxygen will be 1, 2, 3, 4, 5, 6 now. And our hydrogen will be 1, 2, 3, 4 now. So now my oxygen aren't balanced and my hydrogen aren't balanced, but my sulfur and my sodium are. So to balance my hydrogen out, I need to add more hydrogen on my product side. So let's try that. If I put a 2 there, that gives me 4 hydrogen. And it also adds an oxygen. So that would be 6. So just by doing that, I could balance it out. So both have 2 sodium, 6 oxygen, 4 hydrogen, and 1 sulfur. So our answer would be a 2 right there. 1 here. 1 here. You don't got to put the 1s. And 2 right there. All right, going into question number 6. Split that down. We got sodium, we got chlorine, we got fluorine. All right, let's write the same thing on this side. One sodium, 1 chlorine, 2 fluorine. And on this side, we got 1 sodium, 2 chlorine, and 1 fluorine. All right, so our sodium are balanced. Our chlorine, we got less chlorine on this side, so we got to add chlorine on our left side. So let's do that. So we can only add chlorine if we add a whole sodium chloride. So if we add a whole one of those, we have to add a sodium, and we get to add a chlorine. So now chlorine's balanced, but now our sodium's not. So let's go back to sodium. And now we need more on our product side. So in order to add sodium on our product side, we can add that there. But that also adds a fluorine. So let's see how this works for us. Turns out it works pretty well. Look at that. Sodium's balanced, chlorine's balanced, fluorine is balanced. Here's our answer. So we got 2 NaCl, 1 F2, 2 NaF, and 1 Cl2. All right, taking a look at question number 7. This is a type of combustion. So you can see we got propane here going through combustion because we can see it's reacting with oxygen. And we have carbon dioxide and water as the products. All right, so let's write all those down. We got carbon here, we got hydrogen, and we got oxygen. And we got all those on both sides. So as far as carbon goes, we got 3. We got 8 hydrogen, 2 oxygen. On this side, we only got 1 carbon, 2 hydrogen, and 3 oxygen. So you got to make sure you count the oxygen in all your molecules here. So 2 from carbon dioxide, 1 from the water. Now we got to make sure things balance out. It's probably easiest to always do oxygen and hydrogen last, because those are usually the most abundant in a lot of the molecules. So we're going to stick with doing carbon first. So we got 3 on this side, 1 on our product side. That means we need more on our product side. So let's stick a 3 before the carbon dioxide. And if we do that, all of a sudden, we got 3 carbon, but that changes our oxygen. So now we have 6 from the carbon dioxide, 1 from the water. That'll give us 7. So now I got a choice. I could either balance out my hydrogen, or I could try to balance out my oxygen. I'm going to move to hydrogen next, because I can see if I go down to my oxygen, I have to increase my oxygen by multiples of 2, because there's 2 oxygen in an oxygen molecule. And I have an odd number here, so it's not going to balance out right away. So I'm just going to start by balancing out my hydrogen. So in order to do that, I need to increase my coefficient on this side. So if I want to get all the way up to 8, the coefficient I have to stick in here would be a 4. So if I have a coefficient of a 4, that gives me 8 hydrogen on my product side. But that also changes my number of oxygen too. So now it's not 7 anymore. 6 from the carbon dioxide, 4 from the water. That adds up to 10, which is an even number. So now carbon, they balance out. Hydrogen, they balance out. We need to make sure our oxygens balance out now. And in order to get 10 oxygen on this left side, throw a 5 right here. I would need 5 O2 molecules, because 5 times 2 is 10. And now they all balance out. So our answer would be 1 propane, 5 oxygen molecules, 3 carbon dioxide, and 4 water. All right, we are on our last question here. All right, reactants and products. And we got aluminum. And again, look at this. Aluminum all by itself. So we can do aluminum last, because we can just change it to whatever we want. We got hydrogen. And we got chlorine. So that's what we're going to have on this side too. Aluminum, hydrogen, chlorine. We got 1 of each on our reactant side. Product side, 1 aluminum, 2 hydrogen, 3 chlorine. So first thing that I'm going to balance out would be, I'm not going to do the chlorine. I could choose hydrogen or chlorine. I'm going to choose chlorine in this case, because they're farther apart. It's a bigger jump, so we'll go there. So I got 3 on my product side. I got 1 on my reactant side. So let's make 3 on my reactant side. And the way I would do that, I would put a 3 there. And that gives me 3 hydrogen and 3 chlorine. So now my aluminum's balanced, my chlorine's balanced, but my hydrogen is not balanced. So let's increase our hydrogen. And you may notice if I increase it, by 2. So if I put a 2 here, what does that do? That gives me 4 hydrogen, which is more hydrogen than I had on my left side. So now we got to go over to the left side. If I want to balance it out to 4, let's change this to a 4. Then we'll have 4 hydrogen. There we go. It's a 4 now, 4 hydrogen. But the problem with that, you may have noticed it already. If I change that to a 4, yeah, it balances out my hydrogen, but it also increases my chlorine. There we go. So now, taking a look, my aluminum's balanced, hydrogen's balanced, my chlorine is now not balanced again. So I need more chlorine on my product side. All right, so we have to do that by increasing our chlorine here. So by doing that, I have 6 chlorine now. But I also have 2 aluminum. And we don't got to worry about our aluminum. Remember, I could always change this to whatever number of aluminum I want. So we'll worry about that last. So now I got too much chlorine on this side. I need 6 chlorine over here. So easy fix again. I could just change this coefficient. 6. And that'll give me 6 chlorine. But if I do that, again, that changes my hydrogen. I got 6 hydrogen. So now chlorine's balanced. I need more hydrogen on my product side. Let's come back here. Move it up to 3. And here, we have 6 now. So you can see chlorine's balanced, hydrogen's balanced. Now let's just balance our aluminum out. Real easy. We just want 2. There we go. And we got 2. So everything's balanced. Our answer would be 2 aluminum, 6 HCl, excuse me, 3 hydrogen, and 2 aluminum chloride. And that is how you do all 8 of those balancing equation problems.